Imagine if you could leap through time, witnessing the birth of the universe or the end of civilization. A tantalizing thought, isn't it? The concept of time travel has always held a unique allure. From H.G. Wells' The Time Machine to the Back to the Future trilogy, it's a fascination that has permeated our books, films, and imaginations. But what if time travel wasn't just a product of creative minds? What if it was a real, tangible possibility? Some of the greatest minds of our generation have toyed with this idea, and their theories are nothing short of astounding. So, let's delve into this enigma. Let's explore the scientific theories that suggest time travel could be more than just a figment of our imagination. Einstein's theory of relativity, quantum mechanics, wormholes, and even the paradoxes that arise from the concept of time travel all play a part in this captivating puzzle. But how can science possibly justify such a mind-bending concept? Enter wormholes, the universe's potential shortcuts through time and space. These theoretical tunnels, predicted by Einstein's general theory of relativity, could connect distant points in the cosmos, making space travel a breeze. But how might they work? Imagine the universe as a two-dimensional sheet. If we could bend this sheet, bringing 2 points close together, we'd create a shortcut. This is the essence of a wormhole. Instead of traversing the entire sheet, we'd simply step through the wormhole, effectively bypassing the space in between. If this concept seems mind-boggling, don't worry, you're not alone. Even the brightest minds in astrophysics are still grappling with the intricacies of wormholes. But let's entertain this theoretical possibility. If wormholes do exist, they could potentially allow for faster-than-light travel. Now, this doesn't mean we'd be breaking any cosmic speed limits. Instead, we'd be manipulating the fabric of space-time itself, allowing us to reach our destination quicker than light could in normal space. This is where the concept of time travel enters the picture. If we can manipulate space-time to this extent, could we possibly venture into the past or future? Theoretically, yes. Depending on how a wormhole is configured and the motion of matter within it, time travel could indeed be a possibility. But let's not pack our bags for the past or future just yet. The existence of wormholes is purely theoretical, and they're fraught with issues. For one, they're unstable. Without some form of exotic matter to keep them open, they'd collapse in a fraction of a second. And even if we could stabilize them, there's the question of their size. Most calculations suggest they'd be microscopic, hardly large enough to send a human through. Now, let's take a pause and test your knowledge with a trivia question. Who first coined the term wormhole and in what year? So wormholes could be our ticket to the past or future. But is time travel really that simple? Imagine boarding a spaceship and returning to find everyone you knew has aged faster than you. Welcome to time dilation. Time dilation, a concept straight out of science fiction, is actually a very real phenomenon rooted in Albert Einstein's theory of special relativity. Special relativity, in layman's terms, is all about how the laws of physics work the same, no matter how fast you're moving. It's a bundle of complex equations, but its most fascinating implication is that time can stretch and shrink based on your speed. So let's break that down. If you were to hop on a spaceship traveling close to the speed of light, time would pass normally for you on board. You'd celebrate birthdays, holidays, maybe even learn a new language. But when you return to Earth, you'd find that far more time has passed than you experienced. Your friends, your family, even your pet goldfish, they've all aged more than you. It's as if you dipped your toes into the future. This isn't just a theoretical concept, it's been tested and proven. In the 70s, scientists flew atomic clocks around the Earth and compared them to stationary ones. The clocks on the planes, moving at high speeds, ran slower. The difference was minuscule, but it was there. Time had dilated. Now, let's spice things up with a trivia question. If you were to travel at 99% the speed of light for a year, how much time would pass on Earth? Would it be 5 years, 10 years, or maybe even 20 years? Mull it over, and we'll reveal the answer in the next scene. But before we move on, let's take a moment to appreciate the sheer mind-boggling nature of time dilation. It's a concept that challenges our understanding of time itself, showing us that time isn't a constant stream, but a fluid entity, changing based on our perspective and speed. As fascinating as time dilation is, it's not the only paradox that time travel presents. What happens if you travel back in time and prevent your grandparents from meeting? You've just encountered the grandfather paradox. This intriguing conundrum suggests that if you were to travel back in time and alter events that influence your own existence, you'd create a paradox. Because if your grandparents never meet, your parents would never be born, and consequently, neither would you. But if you were never born, How could you have traveled back in time to prevent your grandparents from meeting in the first place? This is the crux of the grandfather paradox, a concept that has stumped physicists and philosophers alike. It questions the linearity of time and the logic of causality. Can the future affect the past, or is time a one-way street? Similar paradoxes abound in the realm of time travel. Take the bootstrap paradox, for instance. This occurs when an object or piece of information sent back in time becomes trapped within an infinite cause-effect loop, where the item has no discernible point of origin. These paradoxes pose significant challenges to the concept of time travel. If the past can be changed, then every moment could spawn an infinite number of timelines, creating a multiverse of histories and futures. It's a mind-bending concept that stretches our understanding of reality. So, here's a trivia question to ponder. If you could travel back in time and change one event, what would you change and how might it affect the present? With all these paradoxes, the reality of time travel seems fraught with complexities. Time travel, a concept that has intrigued us, is shrouded in cosmic enigma. We've journeyed through the wormhole gateway, experienced the time dilation phenomenon, and wrestled with the grandfather paradox. These theories, as fascinating as they are, remain in the realm of speculation. The reality of time travel, though tantalizing, is yet unproven. We continue to seek, to question, to explore. Subscribe to our channel to journey with us further into the cosmos, unraveling its mysteries one video at a time.